Today we're going to look at series and sigma notation. A series is the sum of all terms of a sequence. So what you're going to see is instead of commas between the terms, you're going to have plus signs, basically meaning that we're going to add up the terms of a sequence. Now, the partial sum is the sum of the first n terms and is written as S sub n. So if I said S sub 5, you would find the sum of the first 5 terms. A series can be finite or it can be infinite. And that all depends on what you see as the last term. If the last term is an actual number, then that means it's finite. But if you see that ... at the end, that means it's an infinite series. A series can be written in sigma notation, denoted by, maybe you have seen this symbol before. This is the Greek alphabet letter sigma, and it's a capital letter. There is a lowercase sigma as well. Some of you might be familiar just because of like sororities, fraternities, maybe your brother or sister is in. But sigma means sum. So when you see a sigma, you are going to find the sum of a set of terms in a series. Now, you might have seen also the math team once got a shirt. I know this is so dorky, but it said this on the back. And at the time, you might not have laughed, but now you're going to just LMO, laugh. No, wait, never mind. Never mind that expression. You are just going to find this funny. LOL. Let's go with that one. Square root of -1 is I. 2 cubed is 8. And then sigma means sum. And then pi. Put it all together. What do you got? I ate some pie. I don't know. It was supposed to be a math joke. Maybe you've seen this meme before too. I have. Of course, it's saved in my meme folder. But that is what, whenever you see a sigma, that means. Now, when you're dealing with sigma notation is weird at first. Like the first time you see it, it looks different. But you're going to see that there is a formula written to the right of the sigma. And it's always an explicit formula. Never recursive. The first number that you're going to substitute into the formula is written below the sigma. So you'll see in this example, I would sub in a 1 first, and you keep subbing in numbers until you get to the top number. You sub in the top number as well, but that's the final number you sub in. So this is the first number you sub in. And the top number is the last that you sub in. And then what you're going to do is take all the values that you get and you're going to add them together. You need to remember that when you see a sigma, it means sum. It won't say find the sum, it'll just have the sigma, and you need to know that that means sum. So we're going to talk about how to do this in just a moment, but I just wanted you guys to kind of get that vocab first so it makes a little bit more sense as we do the problems. So for each of these problems, you have different series given to you, and the directions are to write in summation notation. This is the same thing as sigma notation. You'll see that they use different phrases for this, but these are the two that you'll see. So what we're going to do is we're going to start with the sigma. And what we need to do is to the right of the sigma, we need to come up with a rule that represents this, basically the formula. Now notice on the top, it's always a 5, so that's easy. But on the bottom, remember that we call this n equal to 1, n equal to 2, n equal to 3, and so on and so forth. What you're seeing is that the n value, so the term number, is always being added to 1. So when I write my rule, I'm going to say 1 plus n at the bottom. Now, when I write my sigma, you first of all write the rule to the right, but then at the bottom, we need to talk about what's the first number we're going to sub in. Notice that the first number we're going to sub in is 1. Whenever you create a sigma, you want this bottom number to be a 1 or a 0. Mathematically speaking, the easiest is make it a 1. Technically, you could make it a 0, and then you can adjust your rule based on that, but it just gets a little bit complicated. Sometimes you'll see a sigma is given to you and there's a number at the bottom that's not 1, and that's okay too. But just be careful when you set up your rules. Always try to do a 1 at the bottom. And then at the top, we need to think about what is the last number we're going to sub in. And if you notice, the last term here is when n equals to 15, so that would be the top number. Now, they don't want us to evaluate this. They just wanted us to write it in this notation, so that would be done. Later on, we're going to evaluate. Same thing with number 2. So with question number 2, we're going to start with our sigma. And if I ever see a problem with a lot of fractions, I always make like every term a fraction just to help myself out. And then again, you can think about this as n equal to 1, n equal to 2, n equal to 3, n equal to 4, and try to connect that n value to the number that you see there. Sometimes this is easy to do, sometimes it's very hard. Note that the numerator is always 1, and then if I connect the n value to the denominator, at first I was like, well, maybe it is the n value, because if you look at 1 and then you look at 2, but then 3 doesn't connect to 4, 4 doesn't connect to 8 in the same fashion. I am noticing at the bottom, though, this is powers of 2. If you think about it, this is 2 cubed, this is 2 to the second, this is 2 to the first, this is 2 to the 0 power. So if I try to connect that with my n value and look for patterns, notice that it's always 1 less than the n value. So what I could do is I could rewrite this as 2 to the n minus 1 as my rule for this. Now, there's other ways. Don't think that just because I have this answer, there isn't other answers for this. Technically, there's another way you can write this. If you guys think about how this goes back to geometric sequences, where if you look term to term, you can notice that you are actually multiplying each term by a half. Because again, this is powers of 2. So alternatively, you could say the initial value is 1, and then you have this growth factor of 1/2, that r value, and then you can say to the n minus 1. Note that this is actually the same exact thing as what I wrote. So there are different forms of the same thing that you can write. Now, either way, when we set this up, we need to think about the bottom number, and remember that we want to put that bottom number as 1. And just check it too. I mean, you're going to see that right away. It's not going to make sense. If I fill in a 1, I get in the denominator of this 2 to the 0 power, and that does give me that first term. So just make sure that when you fill in, let me put this, I don't like how this is looking. Me no likey. Let me put this to the side. But you can put in that number, and again, you should get that first term. And then finally, you need to figure out what that last term, the n value, would be equal to. Some people like to guess and check. I like to use math. Think about how, okay, that's not funny. Think about how this right here, you have to think about what value of n you sub into this to get this value. So what we could do is we can actually set up an exponential equation to solve this. Now, if you guys remember the exponential unit, I can rewrite this in log form. So I can rewrite this as log base 2 of 128 equals n minus 1. Remember circle of life, 2 to the n minus 1 equals 128. They say the same thing. So what I can do is I can use my calculator, or again, guess and check, nothing wrong with it. Let's go to this right here. So I can, in my calculator, go to the math and do log base, or I could just type in, using the change of base formula, log 128 divided by log 2. And then don't forget that I have to add 1 to that answer. So I get this n value equal to 8, and that would be what goes at the top of your sigma. So put an 8 there. And you can check it. Again, very easy to check. When you sub that 8 in, you're going to see you get 2 to the 7th power, and we just saw that that was 128. So Cool thing about this is that you can easily check every single time. I might have said that already, but that's okay. Moving on to the next one, we are going to write our sigma, and feel free to pause the video if you want to try this one on your own and then check with my key. You can do that for all of these. But for this one, again, I am going to set up my sigma, and then underneath each term, I always just do like the n equal 1, n equal 2, especially when I know it's not like an arithmetic or a geometric one where there's this pattern of adding a number each time or subtracting. And what I can do then is set up my rule. I notice on the top, it's always the n value, and on the bottom, it's always the n value plus 1. Now, for my bottom part of my sigma, again, you always want to say n equal 1 if you can. And then for the top number, this one's a lot easier because of the dot, dot, dot. You're going to love these. Just put an infinity symbol, and that represents that infinite series. So we don't even have to find a top number there. And that one's done. Moving on to the next one. With this next one, we're going to set up our sigma. Now, as I'm doing this, I look at this series, and sometimes I'll put the n equal 1 underneath n equal 2, but what I see right away is that I am adding 3 to each term to get to the next term. And right away, I see that this is arithmetic. With that being said, I can use what I've learned from the past note sheet to write a rule for this using that formula. If you guys remember, the rule is going to be a sub n equals the first term plus n minus 1 times the common difference. So the first term here being 2, and then leave the n minus 1, and our common difference being 3. I always like to simplify, so 2 plus 3n minus 3, I get my rule of 3n minus 1. Now, obviously, if you tried to set up the rule just by looking at the terms and you said, okay, like connecting that n value to this each time, it's not the same visual pattern that you would normally get, and that's why it's important to know these rules. So that means that we are going to put the 3n minus 1 to the right of the sigma. At the bottom, put that n equal 1. And then, just like I did on the other one, if we need to know what value for n we sub in, you could guess and check. I mean, look how easy this one is to guess and check. I'm just going to throw in a 10. I get 30 minus 1. I get 29. It's kind of nice. You can just do that. Or if you want that mathematical way that works every single time, you can solve this. So just set your rule equal to that last term, and then you can solve for n that way and get that answer. So this would be our answer here. Moving on to the next problem, we have another one, sigma notation. With this one, I see that, again, put this underneath, but I see right away that this is a geometric series because I am multiplying by -2 each time. Multiply by -2, multiply by -2. So again, when you write your rule, think about if you ever multiply by a value. A geometric rule, if you recall, is when we have that first term times the ratio to the n minus 1 power. So what I could do is write that first term of 6, my ratio of -2, and then I could put n minus 1. And then note that if I sub in a 1, this is going to work because I'm going to get -2 to the 0 power, which is 1, times that 6. I do get that first term. Because of the dot, 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 I can put infinity on the top of the sigma. Nice box. And then finally, the last one on this page. Again, set up your sigma. You can write n equal 1, n equal 2. Even if you don't use that a lot to create the rule, it's nice to just check it at the end for any term. Now with this one, I am not noticing adding the same value. I'm not seeing multiply by the same value. So when you're not adding, you're not subtracting, multiplying, any of that, and you can't see the pattern that way, that's when you really have to connect each of those numbers to that n value. Right away, I see that this is 2 cubed. This you can technically think of as 1 cubed. 3 cubed, 4 cubed. Again, how did I get that so fast? It's really just practice. I mean, when you do a lot of these, you start seeing, okay, you go through a list in your head, add, subtract, multiply, connect the end value, start thinking powers. Powers usually is the next thing that works. So notice that every time my end value changes, it is being cubed. So this is really just n cubed. Bottom of your sigma is 1. And then if you want to find that last term, n cubed equals 729. Again, you can guess and check, or if you wanted to use your calculator and get that answer faster, we could just do the cube root of 729. So if I go to math, cube root, 729, I get this value of 9. And that goes at the top of my sigma. So that is how you write in sigma notation. What you then have to know how to do is actually find sums. So when you are given problems, sometimes they'll be in sigma notation, sometimes they will not, and it'll say find a certain partial sum. If it ever says find the third partial sum, you're finding S sub 3. Now that means you need to find the first term, the second term, the third term, and add them all up. So I'm going to say A1 plus A2 plus A3. So pretty much same work that you've done, but just add them all up at the end. So if I want to find A sub 1, I'm going to sub in my 1. If I want to find A sub 2, I'm going to sub in my 2. And then if I want to find A sub 3, I'm going to sub in my 3. And then you're going to take those numbers and add them all up. So -2 plus 1 plus 6. So that's going to give me -1 and then 5 as my sum. Now, when you are asked to evaluate a sigma, you're going to learn that if this to the right, this rule to the right, is arithmetic or geometric, there is a formula you can use to make this process easier. If it is not, you cannot use a formula. You have to do this by hand. Now, for this problem, notice it's not arithmetic, because if it was arithmetic, it would be a linear equation. Y equals mx plus b. Don't see that. Geometric would be an exponential equation. Don't see that. So you would have to do this by hand. Now, to do this by hand, remember that even though it says evaluate, when you see a sigma, sigma means sum. Which means that we're going to start by subbing in a 1, because that is our bottom number. So this is the first number you sub in. So when I sub in the 1, I get 1 squared minus 1, or 0. Then you're going to sub in a 2, 2 squared minus 2. So 4 minus 2, 2. Then you're going to sub in a 3. And you keep going until you get to that top number. The top number is the last number you sub in. So for this, did you catch it? I'm sure you did. I'm sure someone's raising their hand right now in the crowd saying, wait, Mrs. Schmear, I got 3 happy. This should be 3 squared. So for those of you that caught that, thank you. Thank you for raising your hand and letting me know. We know this would have always happened. And right now I'm visualizing a couple people who would have raised their hand on this. I feel like period 1, like Kate, Amy, your group back there would have gotten this. And then second period, I feel like Katie would have like raised her hand and let me know that. So thanks ladies for helping me out. Finally, when we sub in that 4 squared minus 4, we get 16 minus 4, or 12. Now, you find all these terms, but remember the whole idea is to now add them all up. So we have 0 plus 2 plus 6 plus 12, and that gives us 20. And that would be how you find the sum of a sigma by hand.